All right, so you want me to just start with 13 or what?
12.
Oh, 12, yeah, 12 is a tricky one to factor.
Plug it.
Okay, so you start out doing number 12 the same way you do the other ones. What can we factor out of each term? Huh? Yeah. Yes, you can factor out 3, and you can also factor out an x. Good. So when I factor out a 3x, here's the difference between these and the other problems where you're doing this factoring. When I factor 3x out of 9x cubed, what am I left with? 3. A 3x squared. Okay? So all the other ones that you did, you just were left with an x squared, but this time we have that 3 in front of there. But that's all right. We have the technology. We can handle it. What am I left with when I factor 3x out of 6x squared? A 2 and an x. Good. And then what am I left with when I... Okay, you guys are answering my questions before I even ask them. Okay, so that's the first step. Any questions on that so far?
No, sir. No, sir.
Okay, so now the hard part is that we have to factor this stuff in here in the parentheses. And the reason why that's challenging is because, like I said, there's a 3 in front of the x squared. Does anyone remember how we do these? We've done these before.
You factor it out.
But how?
Track.
Wrong.
You divide.
Wrong.
You multiply.
Wrong. Kind of right. What do I do? What do I
Oh,
multiply?
inverse.
No. You take this and you multiply the first and the last number together. So instead of looking for two numbers that multiply together to be -1 and add together to be 2, you're going to look for two numbers that multiply together to be -3 and add together to be 2. Because, where did I get the -3 from? 3 times -1, okay? So what two numbers multiply together to be -3 and add to be 2? 3 and -1. Okay, so that means I can rewrite this stuff here as 3x squared plus 3x minus x minus 1. So here's the 3 and here's the -1. Okay? Hopefully this is like vaguely familiar because we spent a lot of time on this. Okay, now I'm going to look at this piece right here. What can I factor out of 3x squared plus 3x? A 3x. And that will leave me with a x plus 1. Okay? What can I factor out of -x minus 1? A negative, yeah, just a negative or a -1. And what will that leave me with? X plus 1. Okay? So this is that thing where, what do you notice about the two things inside the parentheses? They're the same, okay, which means that I did this right. So that means I'm taking this 3x squared plus 2x minus 1, and I'm factoring it into the stuff inside the parentheses times the stuff outside the parentheses. Okay, so that right there is my final answer. Okay? Really? Oh.
I'm just playing. It's Thursday. I'm a little tired.
Yeah. You shouldn't be here.
Yeah, where's Chase Keith?
Mary's not here today. No.
Okay, yeah, the next ones are, yeah, they got me. There's nobody to keep me in line today.
13's 1 and -2.
All right, so now we have some graphing to do.
15 is something. 14, I got -2.
All right, so for the very first one, number 13,
1 and -2.
we are starting with y equals x minus 1 times x plus 2. So what are the two zeros that we know?
1 and -2.
1 and -2. Okay? So now we just need to figure out what's going on in between those points. So give me a number in between 1 and -2.
0.
0. If I take and plug in 0 here for x, what's 0 take away 1? -1 times, if I plug 0 in here for x, 0 plus 2 is 2. And since -1 times 2 is -2, that means when x equals 0, y equals -2. Okay? What's the other number I need to check? -1. So when I plug -1 into here for x, what do I get? -2. And when I plug -1 into here for x, what do I get? 1. And coincidentally, what's -2 times 1? -2 again. Okay, so when x is -1, y is -2. So what's this graph going to look like? A parabola. Is it going to be like this and then go like that?
Yeah.
No, it's a parabola. It's got a nice smooth curve to it like that.
Wow.
Okay?
Got it.
All right?
Good job.
Questions on 13?
No.
Nope.
13 is in the back. 14 is not.
All right. 14. So we're starting with x minus 2
Plus 9.
and x plus 9. Yeah, so this is kind of icky. So where are my zeros? 2
-9.
and -9. 1, 2, 3, 4, 5, 6, 7, 8, 9.
I did back.
All right. So obviously we're not going to plug in all of those points, right?
No.
Okay. What shape is this graph going to have?
Parabola.
It's going to be a parabola, not like this, just like this. Because it's x times x, so it's going to be x squared.
So it'll be
Okay?
down.
Where is the vertex of my parabola going to be?
Oh, I put on
Down.
Where is the vertex of this parabola going to be relative to these 2 points?
0.
Someone besides Alex, please say something.
-2.
Where will the vertex be relative to these 2 points?
right in the middle.
Right in the middle, thank you. Okay, so what point is right in the middle of 2 and -9?
-2. Wait.
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to have to go 1, 2, 3, 4, 5.5.
Yep.
So the vertex is going to be right there at -1, 2, 3.5. So if I can just plug in -3.5, then I'm going to know where the vertex is, and then I can finish my graph. Okay? So -3.5 is a little bit icky, but we can do it. -3.5 in here for x is going to be -5.5 times -3.5 in here for x is going to give me,
-5.
what'd you say?
+5.
+5.5. So -5.5 times +5.5 is what? Angel? -30.25. All right, so I'm not going to get all the way down to -30.25 going by ones. What do you want to go by?
5.
5. So 5, 10, 15, 20, 25, 30. So right down here at -30.25 is going to be my vertex.
Wow.
Good enough for me. Good enough for you? Yeah? Yeah, too much. You guys do your graphic problems, huh?
Yeah.
Meathead, how about stupid head?
That's play we have.
I know. God, you just said a junior high
You
kid.
tell it now.
I do know.
Are you coaching boys?
Yep.
How's that going? There's 14.
Kind of. There's only 9 7th graders, so the 8th grade, some of the 8th graders are going to have to play on the 7th grade.
Oh, that's.
I mean, they'll play on the 8th grade too, but like when our game's done.
Well, that's kind of cool. Just dominate the 7th grade and the 8th grade.
No, we're going to pick the kids that will not be dominating anybody.
Oh, so you got
That's me.
So it's like JV, right?
Kind of, yeah.
That's such a Turkish move.
That's so
Well, what are we supposed to do? There's 4 7th graders on one of
They
these.
don't play with just 4 people.
No, actually.
They probably
Yeah,
that's
I want
not mean at all.
All right, let's do just a couple more, okay, and then we'll cut the graphing thing short. So let's just do 15, 16, and that's, you'll get the idea, all right? All right, so 15, where is that going to cross the x-axis?
Negative 54.
Negative 5.
-5. 1, 2, 3, 4, 5. Where else? Positive 8. 1, 2, 3, 4, 5, 6, 7, 8. Good. And then don't forget 0 also because of this piece right here. Okay? That little x by itself, when that equals 0 when x is 0. All right? Okay, so let's do the little cheating thing again like we did last time. This is going to be, this time, Reed, it's going to be the cubic. So where will the high or low point be relative to these 2 points? Right, like -2.5 right here in the middle. So if I take -2.5 and I plug it in there, -2.5 in for x is just plain old -2.5 times -2.5 in here gives me 2.5 times -2.5 in here gives me -10.5.
14.
Okay, so Angel, do you have that one for me? -2.5 times 2.5 times -10.5. What?
That was an awesome idea.
Don't
It's a
say it.
math field trip.
Save it. Sell it.
Where's it going?
Make money. 65.26. Okay.
I'll tell you what I got.
Okay, so once again, we're obviously not going to go by ones. We're going to go by,
10.
I'm going to go by fives. You can go by tens if you want. 5, 10, 15, 20, 25, 30, 35, 40, 45, 50, 55, 65. So that's going to be way up here. Okay? All right, where is the low point going to be in between these 2 points? At x equals what? What's halfway between 0 and 8? Come on now. 4. 1, 2, 3, 4. So I need to take and plug 4 into there. So that's going to be 4 times 9 times -4. And now I'm in trouble. -16 times 9 is -144. Yeah. So I'm not going to be able to get there by 5s, am I? Okay. So good thing we got by 10s. All right, so I changed this to 10s. So 10, 20, 30, 40, 50, 60, 70. So actually I'm going to put my first point right there. And then this one is -144. So 10, 20, 30, 40, 50, 60, 70, 80, 90. Oh, it's going to be way down there somewhere.
Yeah, that's what I made. That's why I shortened it. Yeah, I mean, a little bit different, but.
A little different?
Like a lot. I shortened it like a lot.
Yeah, I can't reach.
Yeah, I just kind of threw something like that on the graph. All good.
Okay. So it's going to look like that. And again, it's because you have an x and an x and an x, and when you multiply those all together, you get an x cubed. And so this is what the general shape of a cubic function looks like. You see that more. Okay, let's try one more.
No, you did.
We're just be done.
One more. No, one more. Now that you kind of. One more.
I think we should have nap time.
Minus 1.
Okay, so number 16, x plus 1, x minus 2, and x minus 3. Okay, so where are the 3 places that will cross the, okay, -1, 2, and 3. All right. What number do I have to plug in to find the high or low point in between here? Not 1.
Not 0.
0.5, right in the middle there. Okay? So if I put in 0.5 in here for x, that's going to be 1.5 times -1.5 times -2.5. Angel, you on the calculator again for me?
It wasn't me this time.
So,
Thank you. All right, Tony, I'm going to take a chance. I'm going to go by ones. Okay?
No.
So when I plug in 0.5, I get 5.625. So I'm going to go up 1, 2, 3, 4, 5, and a little bit more than a half. What's the number I need to plug in for these 2 points? Nope. What's in between 2 and 3?
2.5.
2.5. So I'm going to plug in 2.5. So 2.5 plus 1 is 3.5. 2.5 minus 2 is a half. And 2.5 minus 3 is negative a half. So 3.5 times 0.5 times negative 0.5. Anybody have that? Huh?
I know you could.
Negative 1/4 times 3.5. A quarter of that is 0.825. 0.8.
I saw you on a lunch date. I saw you on a lunch date yesterday.
0.875. Negative, right? Okay. So at 2.5, it's going to be just right like that.
Your daughter.
Okay.
Yeah,
All
where's your daughter
right.
going?
So that's going to look like this. Okay. And then, like I said, I think you guys get the idea. So we can probably skip the last 2. So why don't you send those on? All right, so today we are going to wrap up this section. So there's actually, I think, like 3 more ideas in here, okay? The first one is pretty simple. What we've been doing so far in this section is we started by factoring the polynomial and using that to find the zeros. Now we're going to go backwards, and we're going to start with the zeros, and we're going to use those to find the polynomial. Okay?
Why?
So if I know that the zeros are negative 2, 2, and 3,
Oh, I know that. That's easy.
then one of the things I'm going to have in parentheses is, x plus 2.
X minus
Another thing, then the plus 2 is because it's the opposite of this. Negative 2 would make this be equal to 0.
X minus 2.
The next thing I'm going to have is x minus 2,
X
because
minus
if I
3.
plug 2 into here, 2 minus 2 is 0. And then for the 3, I get x minus 3.
By the way,
Okay? Nope, because it says write a cubic polynomial function in standard form, so I need to FOIL this out.
Charlie?
Yeah, but we're going backwards.
making a 0.
Okay, right. So what we did before was we started with this, and then we came up with this as the answer. Now they're giving us the answer, and we came up with the question.
but then why do we have to write it in the polynomial function if we have to do that before? We didn't, like,
They want you to be able
We
to do
have
it
the
front
function.
and back.
Right, they want you to be able to do it.
we didn't have that stuff, we just had that and then the.
No, but you factored some. You started with the thing and then factored it into this. So we did that. All right, so I need to FOIL x plus 2 times x minus 2. So first times first is x squared. Outside times outside is?
Zero.
Outside times outside
Oh,
is?
times.
Negative 4.
Negative 2x. Inside times inside is?
2x.
2x. And last times last is? Negative 4. Okay? And then I still have to multiply that by x minus 3. But I can, what? Yeah, I can cancel, I can combine my like terms by canceling those out. So that makes this problem a little bit simpler. Now I'm going to FOIL again. So first times first is
X triple.
x cubed, most math people would say. Outside times outside is
X squared.
negative 3x squared. Inside times inside is
Negative 4x.
negative
Good
4x.
job.
And last times
Negative-
last
no,
is
12. It's
positive
He's so proud
12.
of himself.
Okay, and I'm proud of him too.
You're proud of me?
Yeah.
Even though he's mean to you? He calls you a jerk?
I would call him what he deserves to be called.
You might want to take back being proud of himself.
And
Okay, so you guys see what we did there?
Read.
Okay, so I'm disagreeing with Tony. I'm saying what we did before is we started with this function right here.
Yeah, I get it.
And then we factored it, and then we said, therefore, these are the zeros. Okay, so we're just working our way.
Does that mean we're gonna have some steps where it's just find do the opposite of zero sum?
Okay, so how about if we made things really nasty and said 4 zeros? Okay, so if one of my zeros is -2, what do I have?
2.
X plus 2 times x plus 2 times
Minus 2.
x minus 2 times
Are we gonna do
x minus 3. Okay? So that first step should be really, really easy. You just take the opposite of all of the zeros. Ben, you okay? You got a question for me? Oh, okay, okay, all right. Okay, now I need to, like I did before, multiply this all out, but I'm going to do it in 2 separate pieces. I'm going to multiply these 2 things together and these 2 things together, and then I'm going to multiply those answers together. And it's not going to be pretty, okay? And I'm not going to give you very many of these as an assignment because of that. It gets pretty messy, all right? If I FOIL this out right here, what do I get? X squared plus 2x, good, plus 2x, good, plus 4. Okay? And then Reed has a good math instinct. He doesn't like this to be written like this. So it's really x squared plus 4x plus 4. Okay? But this is all times what I get when I multiply this stuff over here. Okay? So what do you get when you FOIL out x minus 2 times x minus 3? X squared negative 3x negative 2x plus 6. Very good. Okay? And then, yeah, got to combine those. X squared minus 5x plus 6. Okay, now, normally you would multiply those 2 trinomials together. Okay? But if you do that, you're actually going to end up with 9 terms. Okay? And I'm not going to make you do that. All right? So once you get to here, let's call it good. Okay? Do you want me to do it just so you can see one of them?
Wait, so
Okay, so what I would have to do here, if I really wanted to finish out this problem, Tony.
So like, okay, before you do that, so if we get a problem like this though, we don't have to finish
Right, you can leave it like this.
Okay.
Okay? Because let me just show you what the next step would be so you can see the insanity. All right? What I would need to do first is I would need to take every term in here and multiply it first by x squared. So x squared times x squared is x to the 4th. Minus 5x times x squared is minus 5x cubed. And 6 times x squared is 6x squared. Then I need to take every term over here and multiply it by 4x. So 4x times x squared is 4x cubed. 4x times negative 5x is negative 20x squared. And 4x times 6 is 24x. Okay? Then I need to take every term over here and multiply it by 4. So that would give me 4 times x squared is 4x squared. 4 times negative 5x is negative 20x. And 4 times 6 is 24.
Wow.
Okay? So yeah, you end up with 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. Okay? Yeah, so we don't need to do that. Now, yeah, right, we can do some combining. So my final answer really would be x to the 4th. I have negative 5x cubed plus 4x cubed, so those would combine to make negative x cubed. And then I have 6x squared minus 20x squared is negative 14x squared. And then another 4x squared would be negative 10x squared. And then I have 24x minus 20x is 4x. And then I have plus 24. So it all simplify to be that thing right there, all right? Right, yeah. Yeah, yeah. And let me just ask you this. Here's your $1,000,000 question. If I were to graph this, no, I'm not going to make you, but if I were to graph this, tell me 2 things you know about the graph.
It's gonna be
What's it going to be?
It's gonna be
1, 2, 3.
This is a even exponent,
Let me get my chart.
and it's positive, so it's going to be up. Okay, so that's one thing that you would know about this. Where will it cross the x-axis?
not a 0.
Not at 0.
24.
Nope.
Cross it at -2.
Nice. -2
And +3.
and +3
And
2. Okay, now something weird's going on here because it has -2 in there twice. All right, so let's talk about what that's all about. If you have a thing that comes up twice, what that's called is a multiple zero, okay? And they use this fancy word right here, multiplicity, to describe those. And so this right here, we would say has multiplicity 2, because it came up twice, all right? If your zeros were -1, -1, -1, 5, and 7, you would say -1 has multiplicity, no, of 3, because it came up 3 times, okay? So the number of times it shows up is its multiplicity, okay? All right, so let's take a look at this guy right here. How do I figure out what the zeros of that are? If you start with the polynomial, how do you find the zeros? What do I have to do?
you gotta
It's the
get
opposite.
take a
You have to unfold.
Right, I have to unfoil it, which is called factoring. So if I start with x to the 4th minus 2x cubed minus 8x squared, what can I factor out of that?
X
2 and 4.
I can factor out an x squared. I can't factor out a 2 because this doesn't have a 2 here, it's just a 1. Okay? What am I left with if I factor an x squared out of x to the 4th? Good, x squared. Minus 2x, awesome.
8x.
Nope.
8.
Minus 8, yeah, because we took the squared out.
Wait.
Okay, now I can factor this into 2 pieces very easily. What 2 numbers multiply
2
together
and
to
4.
give me -8 and add to be -2?
Never mind. -2 and 4. -2 positive 4. No, -4 positive 2.
-4, +2.
Go, Matt.
Okay, now what you have to recognize is what does x squared mean?
This is multiply everything.
What does x squared mean? Right, you times it by itself. So really what I have here is x times x minus 4 times x plus 2. So what are my zeros? 4 right there. -2 over here. What's going on with the x's? 0. How many times?
Why?
Twice. So that means this is 0 with multiplicity 2. Okay? Great question. What does that do to the graph? Well, let's take a look at the graph and answer that question.
This is why I feel like we should play Pokemon together. We should count cards. All trivia.
I love the game 21.
It loves you.
It does.
Okay, so let's take a look at that question.
There you go.
X to the 4th. Minus 2x cubed. And minus 8x squared.
I wonder if I get these desks far enough, Jeff, if I would.
All right, are you ready? Are you ready?
Here we go. Okay. I got it.
Okay, let's take a look at the graph. So here is our 0 at -2. as we expected. And here is our 0 at positive 4. What's going on right here at 0?
Drop it, that's where the yellow is.
It's crossing the graph right there. It's touching the graph right there, but it doesn't cross it. Okay? So when you have an even multiplicity, what happens to the graph is it comes up right at that point, touches it, and then drops back down. Okay? So anytime a 0 shows up twice, James, you kind of just feel like you haven't even listened to one single thing I've said this whole period. How can you live like that?
Easily.
It's touchy.
So that's what happens when you have a multiplicity of 2. And what you should think of, what you should think of when you see this is a multiplicity of 2 is like a squared, okay? And so it makes like a parabola that touches one time right at that point. All right? So if I do a different one, give me a number.
2.
Okay, I heard 4, so I'm going to go x minus 4 times x
6.
minus, just relax, x minus 4, and then somebody else said 2. What's the multiplicity of that 0 right there, 4? 2, because I put it in there twice. Then somebody else said 2, so I'm just going to do that one time, okay? So what's going to happen here is the graph is going to cross the x-axis at 2, and what happens at 4?
It's only gonna touch
It's
it.
just going to touch it and then go back the other way, right? Yeah, and then run away. So it crosses at 2, and then at 4 it just touches it and then goes back. Okay? So that's what the multiplicity of 2 does, yeah. Next question. What does the multiplicity of 3 look like? Okay, well, 3, a multiplicity of 3 means that it's behaving like a cubic function. So let's look at our most basic cubic function first. Okay, when you have a cubic function, it just touches the graph like that and then goes through, but it kind of levels out. If I zoom in on that, point, you can see that the graph, see how it gets really flat right there and then takes off? So if I have a multiplicity of 3, so if I go x minus 2, I'm going to save myself time. Instead of typing it 3 times, I'm going to just go cube, okay? And then times x minus x plus 4, I don't know. Whoops. Hold on, I don't have it set up right. Okay. So that's where it crosses at -4, and then right here, if I zoom into that point a little bit, it's going to behave,
Wait, why is there that straight line right there?
because that's where it crosses at -4, that's from the x plus 4 part
Is
of
it
it.
still connected?
So,
So if I, hold on a sec, if I zoom in, see how it's behaving the same way as that other graph? It gets there, levels out a little bit, and then goes back
So
up.
when does it start
Okay.
ugly?
Right at that 0, right at x equals 2. So if I really zoom in, see right there at x equals 2, how it flattens out like that and then goes up again. Okay? Yeah.
so like, wait, why is there a straight line that I still don't understand the straight
Oh,
line?
the other one?
Yeah.
Because the function that I wrote had x plus 4 in it also. So where does that cross the x-axis? At -4.
So like, how's that?
So there it is crossing the x-axis at -4.
Connected at the bottom.
Oh, so.
Yeah, it's connected down here somewhere.
So
We
then it
just can't
goes,
see the rest
okay,
of
so like
it.
half of the line is like this and then the other half is.
Yeah, right. So this is like a parabola, and this is like a.
It's a messed up line.
Okay. Hey,
It's not a
Tony,
line.
It's a messed up graph.
you're a messed up graph.
Hey, wait. Hey, I needed that. Go back. Okay, can you press F?
No angry birds on me.
Go down. Down.
Angry birds?
Down. All the way to P.
Oh, wait, what?
P.
What?
Why am I doing this?
Because I want to show you something. I want to see the line.
He's just totally for it.
Keep going. Yes! Click it.
That was a complete waste of time.
Yes.
Big version.
Yes, it was.
All right, so let's try another one here together. So let's take x cubed minus 4x squared plus 4x and find the multiplicities. Huh? Notes, yeah, notes. We'll do this, we can do this together. We're no got it's today, so stay with notes. Okay? What can I factor out of all these?
X
X, not an x squared.
Not an x squared,
just
just
an
an
x.
Quiet people.
And then what's left?
2 squared,
X squared minus 4x plus 4. Okay, now factor the stuff inside the parentheses. Two numbers that multiply together to be positive 4 and add to be negative 2. Negative 4, I mean.
Negative
It would
2
be
and 2.
Negative 2 and negative 2. Okay? Because negative 2 times negative 2 is 4. And negative 2 plus negative 2 is negative 4. Okay? So, what are my zeros?
2 and 0.
2 and 0. How many times did 2 come up? Twice. So 2 has a multiplicity of 2. Okay? Alright? So do you got it?
Got it.
Got it?
Got it. Got it.
Okay, Tony?
Are we ever gonna have to graph this, like, because how would you do that, without a calculator?
Yeah, it'd be pretty hard, and so that's why these problems here say use a graphing calculator to find the relative maximum, relative minimum. We'll get to that another day. All right. Yeah, we are good. So let me give you an assignment.
No.
You come to see like graphing, you can do a whole hard video.
Are you gonna need graph paper?
Or you just read it.
No.
Okay, straight
Don't lie to me.
Don't you do that.
19.
No.
One.
Times
Times 3.
Times 5.
Every 2.
Okay, and remember for these first set, when you have to come up with a polynomial function, if there's 4 of them, if there's 4 zeros, you don't have to go all the way.